Heredity, nature, and nurture. Most scholars agree that there is a constant interplay between nature, heredity, and nurture, the environment. It is difficult to isolate the root of any single characteristic as a result solely of nature or nurture, and most scholars believe that even determining the extent to which nature or nurture impacts a human feature is difficult to answer. In fact, almost all human features are polygenetic, a result of many genes, and multifactorial, a result of many factors, both genetic and environmental. It's as if one's genetic makeup sets up a range of possibilities, which may or may not be realized depending upon one's environmental experiences. For instance, a person might be genetically predisposed to develop diabetes, but the person's lifestyle may determine whether or not they actually develop the disease. This bidirectional interplay between nature and nurture is the epigenetic framework, which suggests that the environment can affect the expression of genes, just as genetic predispositions can impact a person's potentials. And environmental circumstances can trigger symptoms of a genetic disorder. Environment correlations. Environment correlations refer to the process by which genetic factors contribute to variations in the environment. There are three types of genotype-environment correlations. Passive genotype environment correlation occurs when children passively inherit the genes and the environments their family provides. Certain behavioral characteristics, such as being athletically inclined, may run in families. The children have inherited both the genes that would enable success at these activities and given the environmental encouragement to engage in these actions. Evocative genotype environment correlation refers to how the social environment reacts to individuals based on their inherited characteristics. For example, whether one has a more outgoing or shy temperament will affect how he or she is treated by others. Active genotype environment correlation occurs when individuals seek out environments that support their genetic tendencies. This is also referred to as niche picking. For example, children who are musically inclined seek out music instruction and opportunities that facilitate their natural musical ability. Conversely, genotype environment interactions involve genetic susceptibility to the environment. Adoption studies provide evidence for genotype environment interactions. For example, the Early Growth and Development Study followed 360 adopted children and their adopted and biological parents in a longitudinal study. Results have shown that children whose biological parents exhibited psychopathology exhibited significantly fewer behavior problems when their adopted parents used more structured parenting than unstructured. Additionally, elevated psychopathology in adopted parents increased the risk for the children's development of behavior problems, but only when the biological parent's psychopathology was high. Consequently, the results show how environmental effects on behavior differ based on the genotype, especially stressful environments on genetically at-risk children.